In this video, we will learn about K-nearest-neighbors algorithm or KNN, and also understand its working and applications. The K-nearest-neighbors algorithm is a simple, supervised machine learning algorithm that can be used to solve both classification and regression problems. Supervised learning is a type of machine learning in which we teach or train the machine using data which is well labeled. That means some data is already tagged with the correct answer. Consider the given scatter chart. For the sake of simplicity, let's consider that only two factors, humidity and pressure, determine whether it will be a rainy day or not. Each point in the scatter chart represents some value of humidity and pressure. Each and every point is well labeled, which means that apart from humidity and pressure, there is a third property associated with each and every point of the dataset, whose value tells that whether it rained or did not. In this scenario, as we have only two possibilities, rained or did not rain, so the third property can be thought of as a Boolean, rain. Therefore, the value of third property of every single point is either true or false. As we are using scatter chart to represent the dataset, so in order to represent the value of the third property of each and every point, each point is filled with one of the two colors, either red or blue. Rainy days are represented by blue points while non-rainy days are represented by red points. Now, let's talk more about KNN algorithm. Once the machine has access to the labeled dataset, which is also known as training set, then we can input an unlabeled test point, or in other words a point which has values of humidity and pressure but the value of its third property is not known yet. Using the KNN algorithm, the machine will then work with the training set and the test point, and it will predict or output the most probable value of the third property of the test point. It is much easier to understand KNN algorithm using scatter chart. Let's take the values of humidity and pressure of the test point 7 and 3 respectively. By clicking input button, the machine will store these values and it will also plot the test point on the scatter chart. As the value of third property of the test point is not known yet, therefore the test point is not filled with any color. When I will click predict button, the machine will then use KNN algorithm and predict the most probable value of the third property of the test point. Now what happens in KNN algorithm is that the machine will look for k number of nearest neighbors of the test point where k is any odd integer value. Let's assume that the value of k is 5. In this example, 5 red points are located closest to the test point, or in other words, 5 red points are the nearest neighbors of the test point. As most of the nearest neighbors of the test point out of 5 are red points, therefore the machine will predict that the test point must also belong to the category of the red points, or in other words, for humidity equals 7 and pressure equals 3, it will not rain. Let's take another example which will make this concept crystal clear. Let's take the values of humidity and pressure of the test point 5.6 and 7 respectively. Again, let's assume that the value of k is 5. In this example, there are 4 blue and only 1 red point out of those 5 points which are located closest to the test point, or are the nearest neighbors of the test point. As most of the nearest neighbors of the test point out of 5 are blue points, therefore the machine will predict that the test point must also belong to the category of the blue points, or in other words, for humidity equals 5.6 and pressure equals 7, it will rain. Now we understand that how KNN algorithm works, but we also need to understand that how does the machine get to know that which points are the most nearest to the test point. This is where mathematics comes in. The machine calculates the Euclidean distance between the test point and every single point in the training set using the distance formula, hence creating a list of distances. If we assume that k equals 5, then the machine will take those 5 points to be the most nearest to the test point, whose Euclidean distances to the test point are the most lowest ones in the list of distances. There are some cons of using KNN algorithm for every classification problem as well. It is computationally a bit expensive algorithm because it needs to store all the training data. High memory storage required as compared to other supervised learning algorithms. Prediction is slow in case of large value of k. So that's all for this video. In the very next video, we will implement this algorithm using JavaScript in chart.js. Hope you liked the video. Like, comment and subscribe my channel to support me. Also press the bell button to get notified about my new videos. Thank you.